We're on.
Great. Expand 1 plus 3x to the minus 5/3 to 70 powers of x up to infinity the term x cubed. So it's, we've got this thing, we've got a negative non-integer power, so it's ticking all the boxes that mean that you can't use the A plus B formula. And so, if we do this, it's going to be, remember the formula goes 1 plus n times x, and so the n bit is minus 5/3, and the x bit is 3x. And then the next term, remember, was n times n minus 1. So what's n minus 1 going to be?
Minus 8 over 3.
Minus 8 over 3. Good maths. Divided by 2 times the x bit squared. And we're going up to the x cubed term, so we're going to do another one. We're going to have n times n minus 1 times n minus 2. And if we take 2 away from minus 5/3, we're going to get minus 11/3. Over, well, it was 1.2.3, remember? So that's over 6, and we're timesing by 3x cubed. And that takes us up to the x cubed term, and that will be there. We're going to have to be careful with some of the arithmetic here, but this is called for, and you have got a calculator, so you can carefully work these out. What are we going to get?
Minus 5x.
Minus 5x. And then this is going to be a plus eventually. I think working out what we've got here with the 3 squared, this is, you're not going to make this mistake, but you know when you do this with Core 2 students, this bit here catches people out every time, because people see 3x all squared and write down 3x squared. But by this stage, you're not going to do that ever. Fantastic. So this is 9x squared. The 3 times the 3 on the bottom of these fractions will cancel out with that. What have we got? We've got plus 40 divided by 2, so that's plus 20 x squared. And you're working this out in calculators to check that I've done it right. Did you get something different?
No, I was just working out how to do it.
Again, can you see we've got the 3 cubed as the bottom of this fraction, and the 3 cubed here are going to cancel out. Then we've got some other stuff we need to do.
Do you get 220 over 3?
Not got anything yet.
Is it 220 over 3?
Yeah, that's
Yeah,
right.
that's right.
And this one would be negative, wouldn't it? And that's it for the first 3 terms. The question didn't ask us this. But you know, the kind of common thing with these is then to say and state the range of values of x for which it's valid. And it's quite unusual for a question not to do that, but they've given 5 marks for this, which is pretty generous anyway. If we had to do that at the end, then all we do now is we say the region for which it's valid is if the bit that we've used as x is between minus 1 and plus 1. So the bit that we used as x was 3x. So it's valid providing the x values satisfy that inequality. And that inequality would be better written as being x between minus a third and plus a third. And it was unusual for this question not to have done that, but if it had, that's what you would have put. Okay?
So, do you know if it said like 3x instead of 1?
So that again,
If
it
it
said
like 3x instead of 1?
3 and...
Instead of 1 plus x, 3
Oh,
plus...
okay, yeah,
Would
yes.
you take, if you took the 3 out, what would you put as your valid for?
It's whatever you've done when you've done the binomial expansion bit. So if it was a 3 plus x, to the minus 5/3. If your question had been, that, you would have taken the 3 out, wouldn't you? And so you would have said it is 3 lots of 1 plus a third of x
So would you put a third,
to the minus 5/3. And so you're doing 3 to the minus 5/3. Okay, and the bit that you actually are putting into the binomial expansion is the minus third. It's the third of x bit. And so it would be a third of x that's between minus 1 and plus 1. And so that would be a range of values. Stop the video.